be able to talk to a group of people that are really engaged in local issues and, concerned about this region the way it sounds like you guys are. So I'm excited to be here today. And thank you for that great introduction. It sounds like a lot of you are very familiar with the sanctuary. And here is a map that shows you, our location in kind of the northern end of Collier County. And what I think is really interesting and maybe important about the location of Corkscrew Swamp Sanctuary is we're surrounded by a great deal of conservation land. And you can see, the Corkscrew Regional Ecosystem Watershed surrounds us. So the sanctuary itself is 13,000 acres and the Crew watershed is 60,000 acres. So we have that buffer of conservation land that surrounds the sanctuary. But you can see here in Southwest Florida, we don't have as much land in conservation as other parts of the Everglades. And another thing I think is interesting is if you look at the east coast of Florida, development has really built out to their western boundary along the levee that runs on the eastern side of the Everglades. But in Southwest Florida, we have a mosaic landscape that allows development to push farther inland than you would see on the East Coast. So we don't have that hard stop for development where it's, houses, strip malls, and then Everglades. Our landscape is such that development can push farther and farther inland. And I think that's a really important distinction between, and it's natural, it's part of the topography of the system, why that's possible. But I think it's a really important distinction and is going to shape a lot of the issues that we are going to deal with here in Southwest Florida, because they're different than they're dealing with in other parts of the Everglades. In other parts of the Everglades, they don't have as many situations where they have development immediately next to conservation lands, because all of their conservation lands are consolidated into this central Everglades. So I think that's a really important thing, and you'll see how that kind of comes into play. But Corkscrew Swamp Sanctuary is a Ramsar wetland of international importance. We've been identified as a wetland of distinction by the Society of Wetland Scientists, and it's a really important, strategically important, and ecologically important property. And the sanctuary owes its conservation status to the wood stork. The wood stork is, seen here, it's a large colonially nesting wading bird. They're federally threatened. And Corkscrew was preserved and established for wood storks. Historically, the largest colony of wood storks in the US nested at Corkscrew Swamp Sanctuary. The colony was known to Audubon long before the sanctuary was established. In the early 1900s, Audubon actually had a deputized warden living within that colony, armed to protect the colony from plume hunters, which was the biggest threat to the wood storks at that time. That warden lived within that colony until the Migratory Bird Treaty Act came into place and took the pressure off of wading birds in the Everglades. And then that colony, that kind of the next phase of the next threat that came to it was logging, which swept across the system in the 1940s and 1950s. And logging went across the Big Cypress and Big Cypress National Preserve and Fakahatchee Strand and Picayune Strand, Collier Seminole State Park. Logging swept across the system, literally right up to the back door of Corkscrew Swamp Sanctuary. And it was a local effort to try to protect the bald cypress trees within what's now the sanctuary, so that it would not only protect the trees, but protect those birds that everyone knew nested there every year. And so Audubon, was able to acquire the first parcel of land for conservation and established the sanctuary in 1954. And so we've gone through these different phases of, threats to the colony from plume hunting and threats to the colony from logging. And did I do that? No. Sorry, I'm seeing something that's not my screen. Can everyone still see my screen?
Yeah.
Perfect.
Okay. So and what we're seeing now is threats that are coming from outside of our boundary. And so it's kind of a new phase of conservation. We were able to literally kind of draw a circle around the sanctuary and protect what's inside of it. And now we're looking at threats that are coming from outside. So this Wood Stork colony, you know, back in the early 1900s, when the Audubon warden was living within that colony, he had a famous ornithologist visit him in that camp. And at that time, they estimated about over 100,000 wood storks in that colony. Granted, that was probably during, you know, a nesting time, and it was adults and chicks. So it wasn't necessarily 100,000 adults, but that's a lot of wood storks. We started censusing that colony annually right around when the sanctuary was established. During that time, we had, you know, 4 to 5, sometimes even 6,000 nesting pairs at the sanctuary. That was back in the late 1950s, early 1960s. But not long after the sanctuary was established, we started to see those numbers decrease. And we know that decrease was concurrent with development throughout the region. And that, you know, as more people were moving into the area, we were losing the wetlands, that not necessarily the wetlands that they're nesting at, because the sanctuary itself is protected and the nesting trees are protected, but the other surrounding wetlands that we know this species depends on throughout the year. So we saw the colony decrease, you know, up through the 1990s into the early 2000s, but the wood storks still nested at Corkscrew every single year. In the 1960s, they were producing about 1/3 of the US population of wood storks. And while the numbers decreased, they were still nesting every year until about the mid 2000s. And then we saw a change in the pattern where instead of nesting every year, they were not nesting more often than they were nesting. And we noticed a real change in their preference for nesting at the sanctuary. And this is when we started looking into the hydrology, knowing that it was such an important backbone to the system and trying to understand what was going on with the hydrology. We know that in any kind of wetland system, particularly in the Everglades, that water levels drive fish populations. And in the Everglades, the availability of food for wading birds is the limiting factor for their population size. So we know that this connection between water levels and fish and birds is critical for us to understand. And luckily, we had a long-term data set at the sanctuary to be able to tell us how this has changed throughout time. You can see this is the outline of the boardwalk. Here's the Blair Center. And along this boardwalk, we had a couple of different staff gauges and a rainfall gauge that right after the sanctuary was established, we had staff and volunteers collecting data from those gauges every single day. So we had a really unique long-term data set that spanned 60 years that could tell us exactly what was going on with water levels in the sanctuary over that time. So a few years ago, we put these data together and we're able to kind of tell the story of how the sanctuary has changed hydrologically over the years. So this is a picture of what a typical hydrologic year looks like at the sanctuary. We get about 60 inches of rain per year. So the x-axis here goes from the beginning of the wet season through the end of the dry season. So from June 1st to May 31st. And then the y-axis is just the depth of water at one of those staff gauges that's at the lettuce lakes at the sanctuary. And you can see that when the rainy season starts, water levels go up. We reach our highest water level in the beginning of October. And then throughout the rest of the year, water levels slowly fall. And this is nesting season. This is that slow recession or dropping of water levels that allows those fish to concentrate in pools, which is when you see the wading birds really coming in to feed. And they need that concentration to happen because during nesting season, they're catching so many fish to feed their chicks that they need that high energy resource that those drying pools provide. So this is what the system naturally looked like, or what it looked like in the 1960s, at the very beginning of, development in this area. If we flash forward and look at the 1970s, it looks pretty similar. The 1980s, we get decadal patterns in rainfall that change. And so we see it was a little bit wetter in the 1980s. 1990s is a little flatter. But then we saw a really dramatic change when we got to the 2000s. We're still seeing the same peak in the wet season in October here, and it's reaching the same level at the same time, but we're drying out faster, and we're drying out. You didn't see those previous graphs. We didn't see water levels go below ground, but we're seeing that now. We're seeing at the lettuce lakes where our staff gauge is, it dries completely out most years now. So you see this pattern here in the 2000s, and then again in the 2010s, almost even a little bit more dramatically. And if you look at these side by side, the 1960s and the 2010s, you can really see what that change is. The wet season or the rainy season water levels are very much the same as they were historically. The change that we're seeing is in the dry season. And in the dry season, what we're seeing is that we're losing water faster, and we're having dry conditions for longer. When we look at what that means for some of our other habitats, we calculate something called hydroperiod, which is just the number of days per year that water sits on the land. And a bald cypress swamp is going to have a longer hydroperiod than a freshwater marsh because it's wet most of the year. When we looked at that hydroperiod and how it changed through this time, we saw that we were decreasing the hydroperiod by 20 to 30%. In all of our habitats that held water into the dry season, the hydroperiod became about 2 months shorter. So we're just drying everything out sooner and for longer in the dry season. Another way to look at it is, here's a picture taken from the lettuce lakes during one of those dry conditions that we were just talking about, before this meeting started. And from the 1960s to the 1990s, the lettuce lakes dried down about once every 5 years. And from 2000s present, we're drying down about 4 out of every 5 years. And when we dry down, those dry downs are lasting 40% longer. So in the 60s to the 90s, when the lettuce lakes dried down, every 5 years they would dry down, but they would only dry down for a week or so. What we're seeing now is they're drying down for much, much longer. So what does this mean? This over drying of the ecosystem, what does it matter? Well, it matters in a lot of different ways. The first one I've already talked a little bit about is the implications for wildlife, and the fact that less water means fewer fish. And so it's fewer fish that can feed those wood storks and other wading birds. But it also can have direct impacts on wood stork nest success. And there's an interesting mutualism that we see between wood storks and alligators, where wood storks always nest in trees where there is standing water and alligators beneath those trees. The reason they want alligator, and they used to see this as just a weird coincidental relationship. They didn't really understand it. There's been some neat research recently that has shown that even when you put alligator decoys in there, it will cause wood storks to nest in those trees. And the reason has to do with a mutualism where the wood storks are benefiting from nest protection that the alligators provide. Alligators beneath the nesting trees are keeping mammals like raccoons from swimming across the water, climbing those trees, and preying on small nestlings or eating the eggs. The benefit the alligators are getting from that is anything that falls from those nests is theirs. Sometimes that's leftover fish. Sometimes that's a prey item that they brought back that ends up being too big for the chicks to eat. Sometimes it's a chick that slips and falls out of the nest. So there's a really interesting mutualism. And when we lose the standing water beneath the trees, those nests are vulnerable to predators. And we actually saw that at the sanctuary a couple of years ago, where during the dry season, it dried down, and all of a sudden we lost a whole subcolony of nests. And the only thing that we could conclude happened is that raccoons got up those trees and were able to clear out that subcolony, and they did it very quickly. Other implications of overdrying the swamp has to do with our plants, particularly epiphytes. There's a really specific microclimate that things like ghost orchids and other epiphytes require. And when we lose the standing water underneath the canopy of the cypress forest, we're losing the cold temperature buffering. When cold fronts come through in the winter, that the standing water under the cypress trees holds heat and keeps the temperature a little bit higher for those sensitive subtropical plants. It also regulates the humidity under the canopy. So when we lose that standing water, our plants become more vulnerable to overdrying and to cold stress. We also know that lowering the water table increases our fire risk. Not only does it increase our fire risk because a drier landscape lets bigger, even more catastrophic fires come in, but just maintaining our land is much more difficult when we're overdried because we can't do prescribed fire to burn regularly, which causes us to build up fuel loads, which ultimately makes us more vulnerable to catastrophic fires. And we know that, an over-dried corkscrew swamp sanctuary is vulnerable to catastrophic wildfire. We know that when we're really dry in the dry season, the conditions we've been seeing in the last 20 years, if a fire were to get in the sanctuary during that time, we wouldn't be able to put it out because it would be burning the organic matter under the canopy of the cypress. You wouldn't be able to get equipment in on the ground because there's so much soft ground in there. And we essentially would have to wait for water levels to return in the wet season to completely put that fire out. So it would be a disaster if we got fire in the swamp during the dry season. We also know that the less time we have water sitting on the ground in the landscape, the less time we have, we're allowing the aquifer to recharge. So if we're pushing water off the landscape, we're losing the potential for recharging our aquifer, which is where all of our drinking water comes from. We also know that the connections between the inland freshwater and the coast is really important. As we're sending more water to the estuaries, we're giving them more fresh water, which is changing their salinity balance. And we're also changing the less time that water is flowing through our inland wetlands, the less filtration it's getting before it goes to our estuaries. And that means it's going to be carrying more nutrients out to the estuaries. With the problems we've seen lately with red tide and blue-green algae blooms, we know that more nutrients are not something that we need in our estuaries. So one of the important roles of our inland wetlands is to reduce those nutrients before that water reaches the Gulf. So the obvious question is, where's our water going? And what I really wanted to talk about today is, the study that we've recently done to look at where that water is going. And if you think about it logically, the only places our water could be going is being pumped out of the ground, the increased demand on water from agriculture and from residential water use, water management, which is, basically sending water through canals out to the Gulf faster, or increased evapotranspiration. And we know we've seen a change in plant communities over time because we're not burning as much in the region because we've all got more neighbors and we can't do as much prescribed fire when there's more neighbors. And so we're getting some changes in plant communities. And some of those changes we're seeing is going from a community dominated by grasses like sawgrass to a community dominated by shrubs like coastal plain willow, all of which are native plants, but we're just changing the balance of those native plants. And the coastal plain willow, those shrubs that we're getting more of, transpire water faster. So we know that studies have shown that when sawgrass is replaced with this willow, that we're just losing more water just through transpiration. So we did a modeling study over the past year and a half or so that looked at these factors. And I'm going to go through the technical stuff with these results a little bit fast. I'm happy to take more questions on it. But I want to kind of get to the final result of what we found from this. Basically, the model takes all of our current conditions and builds, in a computer model, what our current situation is, where water goes, throughout a year, when we get rain, how the rain moves through the system, the way the canals operate, and it shows how our water moves currently. And what we did in the model was change some of those factors we know are potential causes. The first scenario we ran was we eliminated all agriculture and other groundwater extraction. So we took out all of the wells that were used for irrigation and for drinking water and agriculture. And we looked and said, okay, well, what would that do to the system? And then the next thing we did was get rid of all of those willow that we know have spread throughout the system and say, well, what would that do? And then the third scenario we looked at was getting rid of all the canals and said, okay, well, if we didn't have these canals, what would our system look like? So it was a really simple way, in a way, to look at, which of these factors is the biggest factor that in the changes that we're seeing. So here's just some details of those scenarios. Here you can see the sanctuary outlined in this gray color. And these are all the agriculture fields that sit around the sanctuary that are here in this peach color. And these white dots represent well fields that are pumping groundwater and, for the most part, bringing that water to the coast. So because of saltwater intrusion, the residents that live right on the coast aren't getting their water from underground right where they are. They're going farther inland, and that farther inland is near Corkscrew Swamp Sanctuary. So we looked at what are the impacts of going farther inland around the sanctuary for our drinking water. And when we ran this scenario, we didn't see very much change to the sanctuary. We saw changes in other parts of the system. In Crew, we saw a little bit of a change along the boardwalk when we eliminated both agriculture and public well fields, but it wasn't a really dramatic change. It was kind of a subtle change. So it wasn't anything like the difference between the 1960s and the 2000s, which is the change we were really looking to see. So we didn't think this was, the primary cause. The next scenario we looked at was looking at this willow. And along with willow, we know that pine trees have become more abundant in the system. And the bigger trees and the more trees you have, again, the more water they're taking from the system. So we thinned out all the pine trees in this area and we got rid of the willow, which at this point covers this whole area that's shown here in lavender. We also did a water budget analysis looking specifically at the water use just in the sanctuary, because we're doing some on the ground restoration projects to get rid of willow on our property. To be honest, this is the scenario that we all hoped was the magic answer, because this is something we can do. We can't stop agriculture tomorrow and we can't stop people getting drinking water from the ground, but we could certainly go out and get rid of the willow in the sanctuary. So we were hoping this was the magic answer. So we did that water budget analysis to see exactly what's going to happen when we do this restoration work. And we didn't find much change. So we saw, really subtle change. Certainly with the restoration that we're doing on the ground right now is improving wildlife habitat. We're doing some studies now to better document that. But hydrologically, this change in plant communities that we're seeing isn't what's causing us to lose more water. So then the third scenario we looked at was eliminating downstream drainage and looking at the impact of canals on our area. And we did this in a way that we knew was really unrealistic. We said, okay, well, what if we got rid of all of the canals and water control structures in this area? We weren't saying that in any way to propose that as something that we could actually do. There's obviously, thousands of homes and businesses in this area that we weren't looking to flood, but we were just looking to say, what if? What could we move the needle if we were to eliminate these canals? Could we see a change? So we got rid of all of the canals and water control structures that are inside this yellow polygon here that's immediately south of the sanctuary. And when we do that, we saw a dramatic change in the hydrology. We saw, in red here, or in blue, in these graphs, what you'll see is our current conditions where, in the wet season, water levels come up, in the dry season, water levels fall, and they go down below ground. Ground level is this black line. So here, this blue line, you can see what I showed you in the data from earlier, where we dry down pretty much every year going below ground. When we took out all those canals, what we saw was this red line. where water levels are still going up, they're coming back down, but they're not going all the way down below ground. And we saw this not only for Corkscrew Swamp Sanctuary, we also saw it south of us in Bird Rookery Swamp. So we know that those canals are over drying or over draining not only the sanctuary, but also the state conservation lands to our south. And coincidentally, these conditions that we're seeing are very similar to what we saw, in the 1970s and the 1960s. We also know that the timing of when we saw changes at the sanctuary was similar to the timing of when the canal system was improved so that it would better drain the area along Shady Hollow Boulevard and some of the other areas in the Golden Gate Estates, in that part of Golden Gate Estates. So we know that there were some changes to that they were actively trying to reduce flooding to our south, which it seems like, was, caused the timing was coincidental with when we saw the swamp begin to drain and Bird Rookery Swamp begin to drain. So we did run one final scenario in our modeling where we said, okay, well, what can we do about it? We now know that these canals are over draining the swamp. What could we do to hold on to that water? And what we kind of played with in the model was putting a clay wall underground. We know that what we're losing is dry season water. So it's not surface flooding water, it's groundwater that we're losing. And so we proposed we looked to see what would happen if we put an underground clay wall south of the sanctuary with the goal of holding that groundwater farther north so that it doesn't drain into this canal system that is to our south. That's the primary feature. We also looked at some weirs and some other features that would, also the goal is to try to hold water up north so it doesn't reach that canal system to our south. Obviously, what we want to do is reduce drainage of the sanctuary while at the same time keeping our neighbors and the homes and businesses that are near us from flooding. So trying to find kind of the best of both worlds there. When we did that, we were able to hold some water in the dry season, but we weren't able to hold enough that any of us were really satisfied with that solution. But we demonstrated that there is some engineering that we can do that will hold on to that groundwater. And we just need to figure out the best way to do it. We also found some really significant holes in our data set about this land. So now that we're kind of have gone from this big regional picture and been able to focus in down on the canals and the sanctuary, to understand that that's where the problem is coming from is, to our south there, we need better data in Bird Rookery Swamp and in the sanctuary and in the areas around the sanctuary to really be able to fine tune whatever the solution is going to be. So what we did was kind of our first try at a solution, but we need to keep working on that. And I'll show you exactly what we're looking for in just a minute here. The conclusion of our study was that we found two driving factors significantly impacted the hydrology in the sanctuary. Drainage from our canal system to the greatest extent, and agriculture to a smaller extent. We found that downstream drainage, clearly had the greatest effect, and some of that drainage could be captured through downstream engineering. But we really need to work to engineer a better way to capture that dry season water. We found that groundwater pumping had a negative impact on the sanctuary. I didn't talk much about this, but one of the things we found is that part of the sanctuary that's directly downstream of agriculture, once we turned off the pumps for agriculture in that second scenario, or in that first scenario, that area actually got drier. We found that agriculture is causing that area to get wetter because the farmers are irrigating those fields so much and that water is flowing down into the sanctuary that it's keeping parts of the sanctuary too wet throughout the year, which is the opposite problem than we were looking for. But what's interesting about that is when the area is too wet throughout the year, we can't burn it. We can't manage the land and put prescribed fire on the land because we can't burn an area that has standing water. So it's inhibited our ability to really manage this land and perhaps has contributed to this spread of willow we've seen throughout the sanctuary. And we also found that willow has some site level impacts. On a real small localized scale, we can see a change in hydrology, but overall for the sanctuary, it's not what's causing the water loss that we're seeing. So one of the things that's really nice about Audubon is that our science staff work really closely with our policy staff. So all of this work that I've been talking about, I've done kind of hand in hand with Brad Cornell, who's our Southwest Florida policy associate. And so I'm going to present some of Brad's slides here. I encourage you, if you have more questions about the policy part of this, to reach out to Brad. He's really the one who is the best resource, the most well-versed in the questions I know you're going to have about what can we do, what should we vote on, what should we be engaged in. And I know some of that, but he's going to be your best resource for that. And he's just overall just a great person to talk to about these kind of issues. But he's made some recommendations from the findings of this study. And the first is to address properties that have, excessive flooding vulnerability. This is a picture of Bonita Springs. And we know that there are areas in our region that are flooding consistently and flooding regularly. And we know that over draining the landscape in order to protect those properties is not the solution. So we need to find ways to perhaps go in and conserve those lands and stop building on properties that we know are going to continue to flood year after year. We also need to work to try to reduce some of that stormwater runoff. We've done a lot of that by trying to do more xeriscaping and trying to, not have as many gutters and curbs where we're just sending water into canals, but creating more permeable surfaces so that we can, on a local level and on a localized level, be able to hold on to some of that stormwater so that we're not sending all of our stormwater off to the Gulf. We really need to see greater regional collaboration on some of this work, and not only within the county, but county to county. Corkscrew is in a really weird position where we're right between Collier and Lee counties, and the boundaries for the Big Cypress Basin versus the South Florida Water Management District Basin. We all need to work together, and we need to do more modeling. We need to look big picture on how one restoration project is going to impact another restoration project, and looking at some of these flood mitigation plans. And we need to do all of this collectively so that we're not doing conservation on a piecemeal basis, but doing conservation in a way that we're all working together towards the same goal. We also need to support land acquisition and restoration of strategic parcels. We know that both in terms of habitat connectivity and being able to keep water flowing through the system in a way that mimics natural conditions and allows some of our wetter areas to receive water from wetlands around that. We know that there's the connectance within our region is really important, and we need to look into strategic land acquisition in order to keep some of that connectance. We need, again, to look at some rule changes to avoid development in indefensible floodplains. I touched on that a little bit. And also rule changes to prohibit discharges when there's harm to downstream conservation lands. So we know that north of the sanctuary is a lot of agriculture. We know that agriculture, we've seen from this study, is not only sending us water, but we also know that water is also often filled with nutrients. And we just need to ensure that conservation lands that are downstream of development aren't impacted by any of these factors. Retrofitting existing agricultural, urban, industrial water management systems to stop harm to downstream lands. And we know we need to look into public investments and partnerships in order to do this. We also have concerns about public water supply. We saw from our data that In some cases, when we looked at public water supply, we could see a change in water levels along the boardwalk at the sanctuary, 5 miles away from where the nearest well was when we changed the well, when we got rid of the wells for municipal water supplies and the well fields. So we need to look at on a case-by-case basis when these well fields are going in, how they're going to impact conservation lands in the region. And then we identified some really important next steps in trying to solve this problem. And the first is we need more monitoring. Most of the hydrologic monitoring that's being done now is associated with canals or other water control structures. And that's not going to tell us what's going on in our conservation lands. If we really care about these conservation lands and really want to protect them, we need to know what is going on with the hydrology within those conservation lands. So more widespread hydrologic monitoring is needed. We also identified some holes in the data set that the modelers need to understand the topography of the system. The topography and how, the elevation of our different water level, of our different land types, not only in the sanctuary, but also in Bird Rookery Swamp. They tell us about our capacity to hold water. If you don't know the shape of the land, you don't know how much water you're able to hold within that. Think of it like a big basin or like a big bowl. So understanding the topography of the system is going to tell us our capacity for restoration and will allow us to fine tune that model. And then we know that, and we also have some questions about some of the hydrogeology. There's some underground geologic features that we need to better understand. And then finally, we need to put some more energy into modeling mitigation options. We did kind of a first try with that in our study that we just completed. And we need to fill in some of these data gaps and then go back and model a solution that is going to keep water in the sanctuary throughout the dry season and mimic more natural water conditions or restore natural water conditions. I want to thank the people the modelers that have helped with this study. I'm certainly not a modeler. I'm an ecologist. I've kind of been managing this project and helping with some of the on the ground implications for the sanctuary, but the modelers who actually did the data crunching were the real heroes of this story. I also wanted to include in here, if anyone needs information on how to become a member at the sanctuary or to volunteer. We're finally, hopefully soon, getting our volunteer program back up and running in this kind of post-COVID world that we're living in. We would always love to have more involvement out there. And then finally, I wanted to thank the community outreach sponsors that we have that give me the time to be able to come and talk to groups like yours. And then finally, I'd love to take any questions that you have.